Welcome everyone to this Science Communications webinar. This is part of a series hosted by the Science Communicator in Residence program at the University of Calgary. And did you know this is one of only 2 programs of its kind in Canada? I'm Marianne Moser, the inaugural Science Communicator in Residence, and today I have a guest. Jess Lupini is a Vancouver-based designer, stand-up comedian, filmmaker, and writer. She is a model of the UCalgary motto, Start Something, because after 10 years of creating top-notch science visuals, she started her own company. She is the creative director and co-founder of Avo Media, a boutique agency that specializes in, you got it, science communications. You'll see her work in keynote presentations and videos by leading scientists and science communicators. In her own creative practice, she's a published writer. She's written and produced award-winning short films. She's written and produced podcasts. And she's a stand-up comic. Jess has performed in Just for Laughs Vancouver and regularly appears at comedy clubs across British Columbia. Her stand-up clips have garnered millions of views worldwide, and let me assure you, her esoteric science facts are part of the show. Bringing science to the people in new ways, that's laudable. And I am delighted that she's joining us today to share her expertise in an area that's one of the most important and overlooked topics in communicating science, which is visuals. Today's presentation is 40 minutes long. It's going to go at quite a fast clip and cover a lot of must-knows. So grab your lunch and a notepad and get ready to get good. We'll take a few questions at the end. And with that, Jess, a warm welcome and over to you.
Great. Thanks so much, Marianne. I sound good before I just launch into my endless spiel here. Okay, great.
Yeah.
As Marianne said, this is going to go pretty fast because I am nothing if not full of things I want to share with all of you. So I'm going to jump right into it. This is, are you making these 10 mistakes in your science visuals? Here we go. First of all, I'm delivering this presentation right now on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. What you're seeing is a screenshot from the website native-land.ca, which I really recommend you check out. Not just because it's an important tool to understand whose lands we're standing on, but also because this is a really gorgeous example of design for educational purposes. They've recently switched from showing territories overlapping to this new sort of web of nations that focuses on the interconnectivity of different nations and groups. It's a great website, great resource. I recommend you check it out. All right, into the SciComm. So first thing I want to say is, whether or not you're a designer, you already know how to tell the difference between good and bad science communication visuals. This is a visual called Warming Stripes. It shows the global temperature change from 1850 to 2024. It's by Ed Hawkins. It's all relative to the deviation from the average between 1961 and 2010 each year. And this is a gorgeous visual. We can all see this has high impact. It's incredible. This is a little bit more of a traditional figure showing where that data is coming from. But let's compare this to something else. This is a mass radius diagram looking at exoplanet composition and atmosphere. Now, it's not necessarily a bad visual, but it's probably bad for you. It certainly was bad for me. When I looked at this at first, I had no idea what was going on, and I was completely overwhelmed. I initially took nothing useful out of it. People often struggle with presenting clear ideas visually, but they can usually tell a good visual from a bad visual. And again, this is all relative. It depends on your audience. We're going to talk about that today. The focus today is going to be on understanding what makes visuals effective and a few easy ways that you can improve your visuals in presentations and slide decks, etc. So let's compare apples to apples first here, looking at these 2 essentially versions of the same data. One of them really high impact, very simple. Another one contains more information, but isn't necessarily going to be as high impact at a glance, especially for an audience that might not have a lot of experience looking at data. Why are good visuals important? They reduce cognitive load. They focus in direct learning. They increase the shareability of ideas, which is very important on the internet today. They quickly evoke big emotion, and they contextualize and frame surrounding content. We're going to dive into all of these. I am not above an iceberg analogy, despite how overused they have been in the past. These are things that most of you are probably aware your science visuals are communicating: data, concepts, ideas, and results. There's all this stuff below the surface too. And the reality is, whether you like it or not, when people are looking at the visuals you create and present in a classroom setting or online or social media, these things are being communicated to. All of them can potentially swing in favor of or against you and help you with your message or hinder you along the way. So, a bit about myself: Jess Lupini. I am, in fact, named after the beans, not the other way around. This is a story for another time, but it's a good way of remembering my name if you've ever been in an Italian deli before. This is me at my first science communication job back at the University of Victoria when I was a counselor at Science Venture, which is an ACTUA day camp for kids. This is me getting my face nearly blown off by a bottle rocket. I've been doing science communication for my whole life in a lot of ways. I did take a couple of side tracks along the way. This was a company I worked for a little while. It's a now defunct task management app called Flow. I worked there as a web developer and then iOS developer, a designer. I've worked in film. This is from a short film that I directed and co-wrote a few years back that Marianne alluded to, which, as I've just discovered recently, is extremely popular in South Korea, which I had no idea about. This is a screenshot from a documentary. It's some footage that we captured of a cloud chamber, which is a great way of actually showing radiation in the atmosphere, background radiation. And this is me doing stand-up. I'm also a stand-up comedian. I play Dungeons and Dragons on a live web show, which means I do a lot of storytelling, which is going to become important later. I founded Avo Media 8 years ago with my co-founder, Lucas. He's fantastic as well. A lot of the work that you'll see today are projects. We've had the incredible privilege to get to interview some amazing people, some of whom are childhood heroes of mine. I get to do incredible 3D animation, images, renderings, explainer videos. We did a lot of work during COVID. I'm very lucky to get to do a lot of extremely exciting science communication design that involves a lot of really neat visuals. Some work we did for BC Wildfire Service. Get to do cool animation like this. This is a cover I designed for an issue of Inorganic Chemistry. So, coming back to it. 10 mistakes in your science visuals. What I really should say is, are you making these 10 mistakes in your storytelling? Because all science communication is fundamentally storytelling. So, what's the important part of a story? Well, there are a lot of them. One of them is the plot. So we're going to talk about our first mistake, which is losing the plot. You are a storyteller. You should be trying to tell a single story. This is a single story. That story is our planet is quickly heating up. This is 400 stories at the same time. Let's look at one of them. Look right here. So if you see this, these areas here that have a high density of points, doesn't matter what they are for the moment. Just note that there's a high density there. And then there's this relatively empty area in between them. This is one story that this visual is telling. It's this story, which is small planets tend to come in two sizes, roughly 1.3 Earths wide and 2.5 Earths wide. This is called the small planet radius gap, or the Fulton gap, which basically says that planets of around 1.8 Earths wide are kind of rare for whatever reason. But there's a lot more stories going on here. So how do we keep our stories simple? We'll start with, again, two simple circles. This is something that visuals are great for, comparing two values. And this can look a lot of different ways. How much bigger is A than B? What happens to A over time? How do you follow this particular flowchart or decision tree? This is something, anything with branches tends to work really well in a visual. A lot of people, when I show them a slide like this, they go, well, this is too simple. This is just a single comparison, A versus B. I want to show more complicated, more interesting data. And that's fine. But as soon as we add another value, the important thing to remember is that stuff immediately gets more complicated, sometimes more so than you think. When there's three values, there's actually three different stories here. There's three different comparisons to make. And it gets exponentially worse as we add more values, right? If we have 5 values we're comparing, we have 10 different stories we're telling. 10 individual comparisons, any of which could be the most important one. And the audience isn't going to necessarily know that. That's your job as the communicator. 10 stories, probably too many stories. So let's look at this example with 3 values. It also matters which stories you want to tell or emphasize. So here's how you can focus attention. We've talked about these 3 different stories, but maybe we don't care about all of them. Maybe we don't care about this story. All we care about is the relationship between each of the smaller circles and that one bigger circle. How would we emphasize that? Well, we can do that with positioning. We don't care about this relationship. We just established that. It's distracting and it's making it hard to see the relationship between the yellow and the pink balls. So if we position them differently, this lets us focus on those relationships that actually matter, that we've decided ahead of time are the story we want to tell. Let's look at an actual real life example. Now you're seeing why I've talked so much about circles. This is the real example I worked on recently. It doesn't matter so much what it's actually showing, but very quickly, it's visualizing the agricultural co-products produced in the Canadian prairies. So co-products are secondary byproducts that are produced alongside the primary product. For example, when you make canola oil, excuse me, when you make canola oil, it makes a lot of canola meal along with it. Canola meal is usually used as a cheap, high-protein livestock feed. We were asked to make a summary document from the report that this figure was in. The target audience was policymakers who were in a rush and needed a quick brief. Basically, a picture book for policymakers was the goal. That's our audience. So how can we simplify this story for our audience? Well, there's actually 2 data sets here is the first thing. There's this top set of circles, which are the actual numbers from 2024, and then the bottom circles, which are the projected numbers for 2030. That's all we care about, since this report is focusing on the potential use of these co-products. So we threw out the 2024 numbers. Oops, sorry, I skipped ahead. It's already better, right, when we're covering up these and only looking at one set. It was important to the client that we showed all of these circles, but I was able to use a few tricks to make it easier for people to look at a glance. So I already spoiled this a bit, but this was the version we ended up with. A few important notes about this. You'll notice that none of these circles look small. They're all big with big text in them, bold, large numbers. That was really deliberate because the goal wasn't to compare each of those circles to each other. The goal was that a reader would be able to look at them and quickly go, there's a lot of all of this stuff being produced. You can see some of them are bigger than others, but we're de-emphasizing the relationships between them and superimposing them on top of that faded out image of the prairie provinces, the Canadian prairie provinces, which again, emphasizes the relationship between all of these as a group and Canada. These are large. There's a large volume of these produced. Other little details, we wrote million metric tons in instead of MMT, so we didn't need to define a term. We're all trying to focus on this being quickly understandable and digestible. And you can see it feels a lot easier to understand that image on the left at a glance. So how do we avoid losing the plot? Simple, we tell a clear, single story. All right, number 2, weakening your story with the wrong visuals. This is a really common one. So here's a little bit of data for you. These are the 2025 GDPs of 2 countries you may recognize. Here's one way you might visualize these. In fact, this is a very common way people visualize these. I generally have a distaste for pie charts, not always, but a lot of the time. And one of the reasons is this happens all the time. The issue here is that pie charts are for showing what the part is of a whole. And in this case, we can't see the whole. Sure, we're comparing the Canadian and US GDPs, but what we should be showing is the proportion of them relative to the whole of something, which in this case should be the world. Now, this starts to make a little bit more sense. Even more so if we turn it into a donut. But this visual would probably be better as a waffle chart. It's a lot easier to see this relationship right here. This is a pie chart that I do quite like because it's silly. Here's a real life example. A few years ago, we were asked to help with a lecture series at Science World in Vancouver. Dr. Stanley Yen, who's a neutrino physicist at UBC, was doing a presentation about neutrinos. We worked with him to help make the presentation more visually interesting and accessible to the general public. This was a slide from his presentation with the goal of illustrating how you can view the universe through not just visible light, but also different types of electromagnetic radiation. Images can be really powerful, but not these images. But we did notice something while looking at this slide, which is that these two ellipses look really similar to each other. And that's because they're both showing the night sky in different wavelengths, microwave and gamma rays, respectively. So jumping off of that idea, this is what we ended up doing to help him with this presentation. First, showing visible light in a rainbow, then how it's part of the much larger spectrum of radiation, and then showing how we can view the night sky in visible light, right? This is looking up at our sky, the way our eyes see it. Or we can view it in infrared, or microwave, or FM radio waves, or X-rays, or gamma rays. And this visualization is powerful because it connects back to something that we all understand and know, which is what we see looking up at the night sky. And then we build upon that. And people are left understanding that there are other ways to see the sky, to see the universe. And that segues well into neutrinos. So how do we avoid weakening our story with the wrong visuals? The solution is we match the best visual to our story. All right, let's move on to number 3. Yeah, what I actually mean by this is the mistake is drowning your art in words, to using too much text. Slideshows have visuals and voice in them. The visuals don't stand on their own because they don't need to stand on their own, right? There's a difference between a slideshow with a speaker like we have right now and a handout that you'd give to people to read on their own time. Think about how you're telling the story while the visual is up. You're probably familiar with these scientific posters. This is a great example by Colin Purrington of a bad scientific poster where he's done almost everything wrong. One of the worst offenses here being to add as much text as possible. And this is deliberate, by the way. He's deliberately trying to show what not to do when creating a scientific poster. This is a fun resource. Looking at a real life example, this is Dr. Rhonda Patrick. You might have seen her videos on YouTube. She's quite a prolific presenter and science communicator. If you've seen any of her live presentations, you've probably seen some visuals that I've designed in the background. This is an example of a slide that she gave me to work on to improve a little bit in one of her presentations, looking at how sauna can lower hypertension based on one study. This was an early version of it that I came up with, starting to sort of play with ways of reducing the amount of text on the slide to make it easier for people to immediately understand, see what's going on, comparing the effect of 2 to 3 times a week with 4 to 7 times a week. And then I started to go further with it. There's a lot of iteration that's going to come up as a theme in this. This was a version of it that had even less text. Although I did start to feel like I'd maybe lost something here a little bit. Eventually, I ended up back here as another way of showing this, how these different sort of schedules in the calendar had this effect on hypertension risk. But then I ended up back here, getting rid of the calendar completely. There's a lot of iteration here, trying to find the right balance of too much text and not enough text, but ultimately letting Rhonda tell the story. This is just a tiny portion of what my sort of scratch pad looked like trying to design this. Your first attempt to design the right visual is almost never right. It's never the best way. You have to work through, sometimes you have to overcorrect to figure out where to stop. Another really quick example, again, from Dr. Stanley N's presentation. This is what we got from him. There's a story on here, but he was telling that story verbally. So we just showed something pretty that's a good way of helping the audience visualize what he's talking about and then let him tell the story. So how do we avoid drowning our art in words? We use text sparingly. Number 4, we're ripping through these, trying to get too fancy. This is, again, a very, very common thing we see. Here's a great example of an over-designed visual from McKinsey and Company, of all people. The more you look at this, the more you'll realize it's basically nonsense. The entire graphic is just saying design is important. That's it. None of this is adding anything to it. It's what I often refer to as a hat on a hat. People are going to be so distracted trying to figure out what each of these design elements mean that they'll miss the entire point of the graphic, which again is just design is important, ironically. It's an over-designed visual because none of these design concepts are actually improving comprehension. None of them are helping the viewer understand what's going on. They're actually hindering it. And the problem is that the current evolution of design is pushing you and I to do this too. Some of you may have used Canva. It's a really popular design tool right now. All of these, which are some of the most popular templates in Canva that you will get shown if you start using it, these all are over-designed in a lot of ways. They're pushing you to add too much content to your slides, which again is kind of counterintuitively hurting comprehension. So I would really suggest trying to keep things as simple as possible. An example I often use is you don't need to be able to draw an incredible illustrated goose to show a goose. You can just draw a goose like this. Now, it does help that I showed you the illustrated goose first because it primed you for it. But that priming is also a really useful tool, right? You can prime people by showing something ahead of time. Here's another one that I haven't primed you for, but I have primed you for the fact that some black shapes on a white background represent an animal. So you might be seeing already that this is a beaver. And now that you've seen the beaver, you probably recognize that this is still a beaver. But you might not have if it was the first thing I showed you, which might have been that overcorrection I was talking about. Another way that people tend to over-design is by using the only thing I hate more than pie charts, which is 3D pie charts or 3D graphs of any kind. These are wholly unnecessary most of the time. One of the main reasons is that perspective makes it really hard to tell sizes and proportions. Can you tell whether Canada or Germany has a larger GDP? It's kind of difficult because of the perspective. And as it turns out, it is in fact Germany. Were you able to tell how much bigger Germany's was? I doubt it. Similarly, 3D bar graphs. Which of these points are you supposed to use to figure out what the GDP of the USA is? As it turns out, none of them. It's up here. But the perspective really throws you off. And last example, color scales. This is incomprehensible because there's just too much going on with the color scale. And this is real data, but I've deliberately made it hard to read by using a terrible color scale. All you need for stuff like this, most of the time, is black and white or a single color. And if you want to include multiple colors, make sure they're on a spectrum that we intuitively understand as humans, like a sort of heat, flame, fire spectrum like this, where we have yellow, orange, and red. And it's very easy to look and see the areas of high population growth. So how do we avoid trying to get too fancy? The solution, we keep it simple. All right, number 5, forgetting to look through other people's eyes. This is a big one. Here's a set of eyes. And by a set of eyes, what I actually mean is this is a figure showing the proportions of normal color vision, color blindness, and carrier in the population in XX and XY genotypes. If you're having trouble reading this or seeing it, it's because I put a filter over it that shows what it would look like if you were a particular type of colorblind. If you are colorblind and you're watching this, I'm very sorry. This is what it would look like without that filter. These aren't great colors, but the truth is, a lot of colors that people choose all the time end up at least having 2 of them that look really similar to people with different types of color blindness. And that can be a real challenge for accessibility. Here's a version of this that I then designed just in black and white, which I think is a lot clearer looking at these 2. But I hate this. I hate what I've done here. I added it to prove a point, but it's doing too much, right? What's the goal here? There's too many stories. Am I trying to compare the number of colorblind people with XX chromosomes to XY? Am I trying to show how only people with XX chromosomes could be asymptomatic carriers? What story am I trying to tell here? So then I started iterating again. I tried a version like this that has no text, playing with those symbols for male and female. And then I think I went too far. I got too fancy with it. Do people even know what these symbols mean? A lot of people do. A lot of people don't. That's an accessibility consideration too. This is clearer if you don't know the symbols. It's that waffle chart again, because it explicitly says female. But now this is not inclusive in another way, right? The way the word female is used in a medical or scientific context is different from how a lot of the general public uses it. And we start to get into conversations around gender identity versus sex versus genotype. And seeing through other people's eyes, which is what this section's about, is not just about accessibility, it's also about inclusivity. So this would be technically more accurate, right? Talking about the XX genotype as opposed to saying female, but it's harder to understand, especially for people who don't know what a genotype is, which is a lot of people. We could use these symbols, which are more well-known, but now we're implying that the XX genotype is synonymous with wearing a dress, which has its own problems too. The reality is that this version is probably the clearest and most accessible to the most people, but it's also the least inclusive from the perspective of trans or gender diverse people. Um, the truth is, I'm not going to show you a perfect version of this chart because there isn't one. There's always trade-offs. And what I'm telling you that for is not to freak you out. It's so that when you're thinking about these choices you're making them deliberately and understanding what those trade-offs are, because each of these is going to hit differently with a different audience. And if you're not thinking about what those trade-offs are, then you're kind of just designing in the dark. And it is often a miracle when the audience connects with something that was designed in the dark. There's other stuff to think about too for accessibility, contrast, size. You can look up WCAG, the Web Content Accessibility Guidelines, as a good place to start. There's a lot of ways of checking your slides and graphs to see whether they meet these standards. Okay, so how do we avoid forgetting to look through other people's eyes? The solution is we make everything as accessible and as inclusive as possible when we can. All right, ignoring the context of your content. Here's another one, mistake number 6. This is Dr. Michael Greger. He's somebody that we worked with a lot at his nonprofit nutritionfacts.org. This is him doing a presentation called How Not to Age based on a New York Times bestselling book that he wrote a couple years ago. Part of this presentation involves him talking about atherosclerosis. And he specifically talks about what the arteries in the brain look like normally, and then goes to this slide, showing what they look like with atherosclerosis. This is a big emotional moment in the presentation. The audience audibly gasps when he does this as a live show. It's because he knows that showing these two slides back to back is way more impactful than showing them in this context, the way that those images are presented in the original paper. He could have showed it like this, but he understands this is way higher impact because he's telling a story. Stories are memorable to people because of the emotions they elicit. As much as we might want our audience to be completely engaged by simple facts and data alone, we're human beings. Our brains are fueled by emotions and feelings. Trying to engage an audience without using emotion is like trying to use gasoline to charge your phone. It's simply the wrong fuel. It's never going to work unless you use the gasoline to fuel a generator, and then you use that to charge the phone. In this case, the generator is storytelling, right? It's the tool that converts ideas, data into emotions and feelings, the things that connect with humans. That's your job, is to be that generator. Another thing here is references and additional information. I'll quickly cover this. Do we need to show this full figure description at the bottom? Maybe we could just put a URL if we want people to be able to find the original source. That might work in a PDF or an email, but if you're printing these out and putting them up as posters, it's going to look pretty silly, right? No one's going to type these out. And I'm using an over-the-top example to be a little bit funny here, but I do think this is a good example of a place where a QR code might be a better tool to use. These are easy to make online. Adobe has a free QR code generator. Here's a real-life example. This is from that Prairie co-product report that I showed you earlier. We needed to make a version that would work as a PDF and could be printed out and used online. So we have QR codes that are also links, and there's a URL below if people want to type them up. So this is incredibly easy, no matter how you're viewing it, to get to those sources and find more information. So how do we avoid ignoring the context of our content? Solution: we make design decisions based on where and how people will view it. All right, number 7. Breaking rules we didn't know existed. This is a map of a major Canadian coastal city. See if you can tell which one it is. If you're having trouble, this might make it easier. Okay, what about now? Maybe you're able to recognize now it's Vancouver. The reason it was really hard at first is because I broke 2 rules, implicit rules of maps, which are north is up and water is blue. These are probably obvious to you, right? We all know these rules. But what you need to know is that your brain is also doing this for everything else. Not all of these rules are obvious. Sometimes it sucks to have to follow these. You might have a better way of showing something, but you need to recognize that when you break implicit rules, people often take longer to understand something. When time is of the essence, as it is right now, as I've crammed way too much information into this presentation, you want to make sure people stay engaged, focused, and keep their cognitive load low. Left to right doesn't apply in every language. It certainly is the case in English in North America. These other ones are also very common, big to small, top to bottom. These are the order that people consume information. It's how I know that this will work. You will read this slide in the order that I expect. This is a great example of heading hierarchy, right? Different headings really matter, not just for organization, but also because they affect where people will look and what they will focus on, right? So use your headings when you're making a Google Doc. And to help you remember how important that is, think of heading like a compass heading. It shows you where to go on the page and on a slide. You also have another even better way to control the order that people consume content in, which is by using more slides with less content. You had no choice but to read that in the order that I wanted you to. This, I'll just show for a second. This is a very cool analysis and visualization by scienceux.org. What you're seeing is where people's eyes are looking. This is an eye tracking study showing where people's eyes are looking on scientific posters. And the areas that are orange or red are the places where a lot of people are looking at the same time. This is a great resource for sort of seeing how people will scan heading hierarchy and colors and fonts and text and sizes and images. And you'll notice that there's some places that don't get looked at until quite late in the game. Maybe that's what you want, but if you have something really important that's in a place that people are looking last, they're probably not going to see it. Okay. These implicit rules exist in charts, graphs, and diagrams too. This is a horrible graph because it breaks an implicit rule. You may have spotted it already, but that rule is that higher up on the y-axis is usually a bigger number. And in this case, the lower number. It might be clearer if I flip this graph upside down. This is what it's actually showing. And you can see that gun deaths in Florida actually increased significantly when that stand your ground law was introduced in 2005. But the initial presentation of it kind of makes it look like they dropped. Now, here is a graph that breaks the same rule. It does the same thing. But this is an excellent graph. It's an award-winning graph, actually, by Simon Scar for the South China Morning Post, looking at the death toll in Iraq. So why is one of these great and the other one a disaster? The answer is a lot of little things, and they all come back to storytelling, right? When we look at lines, we tend to be focused on a trend or on a change, how much the line is going up or down. And that's such a strong impulse that it overrides the biggest visual clue that something is weird about the graph on the left, which is that that area above the line is shaded. It's not until you look closer that you actually clock that the y-axis is not what you might expect. Whereas for this one on the right, we tend to perceive bar graphs as a bunch of discrete values. We can tell that each bar is showing something different and unique. The big text at the top primes us for blood. And the color of the text reinforces that, or the data set rather, reinforces that more red equals more death. You might still not realize that the y-axis is flipped intellectually until later, but you've already understood implicitly that the longer the line, the more deaths. So the one on the right is rightly an award-winning graph that does break an implicit rule of graph design. And I have this in here to show why you should not break these rules unless you really know what you're doing. The graph on the left was not created maliciously. I do not believe the designer, it was created by Reuters. I do not believe they had any ill intent whatsoever. However, I think they were trying to do what Simon Scar did with this Iraq graph and ultimately failed because they didn't quite understand how to tell the right story while breaking a few of those implicit rules. So how do we avoid breaking rules we don't know existed? We try to follow the rules most of the time so that when you break them occasionally, intentionally, it's going to be effective. All right. Copy, paste, done. Sometimes I see people will find a great image or reference and copy and paste it into their slides, infographic, website, post. Don't do this. This graph is amazing. I have it here to discuss it from a creative point of view, but if I was doing a presentation on the death toll in Iraq, I should not include this as it is. There's a lot going on. First of all, it's not in the right aspect ratio, right? It's a portrait graph in a widescreen format. So we're losing a lot of information on the side. Nothing wrong with white space, but you want it to be intentional. There's also a lot going on. I don't expect an audience to read everything in this graph during a presentation. And if I did, then why am I teaching in the first place? Why not just hand them out a PDF? I even had to cover up some parts of this graph while I was showing it to you earlier to make sure I wasn't distracting you from the point I was trying to make. I'd probably do something like this if I was doing a presentation about this graph, um, putting it more in a format that looks good in a slide, maybe even something like this. If you're wondering how to make something like this, there's a lot of great tools for capturing data from graphs. And then you can use Excel or numbers to make that kind of thing. WebPlot Digitizer is a great tool for capturing data from graphs. It's one that I use all the time. Real life example, this is a slide from Rhonda Patrick for a presentation she was working on, looking at circulating tumor cells and how the mechanical stress on them during exercise could actually rip them apart. This is the version I made for her. Comparing these two images to each other, you can see how, rather than just copying and pasting it into the presentation, I am updating it and adjusting it and making a version that fits not only Rhonda's visual style, but also includes the information that we're trying to communicate clearly. All right, copy paste done. How do we avoid this? We share other people's stories, but adapt them for your audience and your medium. All right, leaning too hard on pop culture or niche references. This is a quick one. A lot of us are guilty of putting XKCD comics in our slide decks. Not necessarily anything wrong with that. If I were discussing this 2026 paper in Current Biology, flexible use of a multi-purpose tool by a cow, I would have a very hard time not including one of my favorite cartoons of all time, Cow Tools by Gary Larson. And I think we would all agree this is a good choice, right? Pop culture references can be really powerful ways of quickly connecting with audiences and making connections between things that they already know and new ideas. But it's not always a good idea. A common example is in metaphors for concepts that we tend to use a lot. Take overfitting, for example, which is a mathematical modeling concept. If I were explaining this to a general audience, I would want to use a general metaphor. So it might be a mistake to say, well, if you're playing Dark Souls, a good example of overfitting would be if you built your entire build of your character for Dancer of the Boreal Valley, then when you went to fight Osiris, the Consumed King, you would have a much harder time with that particular build. If you're not a gamer, if you don't play Dark Souls, you're probably going, what on earth is going on here? And I've lost you. If you do play Dark Souls, you're probably more engaged than you've ever been in your life in a webinar. But for an audience like you, where frankly, I assume most of you are not gamers, it wouldn't be safe for me to assume you all play Dark Souls, a niche game, I should use something more general. Like, for example, I could describe overfitting as, let's say you're taking an exam. If you have an exam coming up and the way you study is by memorizing all the previous answers to practice exams, you're probably overfitting for the data, right? You have all that data stored in your head, but if there's a single new question on a real exam that didn't show up on a practice exam, your model would fail to predict that future value. You should have been studying the material rather than just the multiple choice answers to previous exams, and that's overfitting. Or looking at another cartoon example, if you're talking about cherry picking data, you could show this Dilbert cartoon, which is a good cartoon to talk about when you're talking about cherry picking. It's funny and relevant, but what some of you probably already know, and probably some of you don't, is that Scott Adams, the creator of Dilbert, was, to put it kindly, a ghoul. The comic strip was dropped from almost every newspaper a few years ago after a racist rant he went on. And sure, you could separate the art from the artist, etc. But is it worth the risk of alienating your audience or even just distracting them if they start to wonder whether or not you know? It's up to you, but make sure you're thinking about it when you drop these kinds of things in. Gary Larson, as far as I know, does not have any drama around him to date. So how do we avoid leaning too hard on pop culture and niche references? We use universal references whenever possible. Okay, last one. I can see I'm getting to the end of time here. Asking a computer to do a human's job. We're going to talk about AI because we have to. These images that you saw earlier are AI generated. I'm not going to touch on the ethical considerations of using AI right now because I think that's an entire huge conversation that we don't have time for in this presentation. But let's talk about efficacy. In this case, these illustrations accomplish their goal. Any inaccuracies in the anatomy of the creatures or the background are not a big deal because they didn't affect the point I was trying to make with them about design. But that's not always the case. You may or may not have seen this absolutely horrible image before. If you haven't, this is a real figure from a real, famously now redacted paper published in Frontiers of Cell and Developmental Biology in 2024. It was created by Midjourney. Okay, but that was in 2024, right? Image generators have gotten better. Well, what's the state right now? This is looking at the number of papers that were, or the number of journals that were looked at in a study in BMC Primary Care last year. They were looking at family medicine journals' AI policies. What they found was 50% of them allowed AI-generated images, and the rest were divided between having no policy or explicitly forbidding AI-generated images in papers. Here's that data that we just looked at, written out in text form. Let's see what happens if we get AI to try and generate a figure showing it. This is a popular tool called Stork that purports to do scientific figures through AI generation. This is accurate, but it's not a great way of showing that data. It's very confusing. It takes a while to figure out what's going on. I asked Stork to make it more modern and visually interesting, and this is what it did. Not particularly helpful as a designer. Just glowy. This is another popular one called Figure Labs. What are quadrants? Why are there A, B, C, and D quadrants? That's completely made up. It's nonsense. This is when I asked it to make a Sankey diagram. You'll notice that the percentages do not add up as they should to 100%. This is a disaster. And Stork did exactly the same thing with its Sankey diagram. Okay, what about the rat example, the famous rat example? Has this gotten any better? Well, this is what Gemini did. I'm not even going to talk about what's going on the left. Suffice to say, this is not great. And here's what a popular free tool called SciDraw did. And I think this best illustrates one of the simplest problems with AI-generated content, which is they make up so much information. What the heck are these? What is this? This is complete nonsense. It's completely made up, which is really scary when it comes to looking at data and science. So how do we avoid asking a computer to do a human's job? We avoid using AI when comprehension is on the line specifically. I'm not going to put up a summary slide with all the things we've learned because it would be too much text. So I just want you to remember the most important thing, which is that you are a storyteller and you need to know your audience and tell them a good story. I haven't really talked about Media, but these are some of the companies that we've worked with over the years. It's been very wonderful getting to work for this company. You can find our website there. And with that, I am done. If you have any questions, if there's time for it now, we could do it. I don't know if we're out of time. And if not, you can always send me an email.